let's take a look at the second part of this section, the binomial series. So first of all, we need to define the binomial coefficient, and this is the binomial coefficient. It's p choose k, that's the binomial coefficient. And then how do we define that? It's defined here, p times p minus 1 times p minus 2 down to p minus k plus 1 divided by k factorial. And then of course we need to define a special case, p choose 0. Okay, so how do we read this? We read p choose k, so this is p choose 0. This binomial coefficient actually it has some meaning. When p and k are integers, if p is greater than k, like for instance this scenario, this example, 7 choose 3, that means how many ways to choose 3 subjects from 7 subjects. For instance, suppose we have 7 students, how many ways to choose 3 students to form a committee, for instance, then that's 7 choose 3 number of ways. Alright, so now let's follow the formula, do some algebra. So that's the first objective, know how to do these algebra. Okay, let's begin with 7 choose 3. Now according to the definition, it will be 7, which is your p, right? 7, and then the next one will be 6, and the next one will be 5. And when do you stop? You're gonna stop at 7 minus 3 plus 1. Okay, that's what it says, p minus k plus 1. In this case, that means 5. So when you see 5, you stop. The bottom one, you just do the 3 factorial. Okay, so if you do the algebra, this is like 3 factorial is 6. 6 cancel out with 6. 5 times 7, which is 35. Okay, that's how we compute 7 choose 3. And another way to make a quick comment here, 7 choose 3. So a quick way to do that is, okay, how many numbers you have? 3 numbers you have on the top. This tells you that how many numbers you have on top. It's just 7 times 6 times 5. And the bottom one is just 3 factorial. Right, so this is the quick kind of how do you know how many numbers on top. Okay, 12 choose 1, that means how many ways to choose 1 student from 12 students. It's just 12 ways. It's just 12 over 1. And why just 12? Because it says 1 right here, so you have only 1 number on top. The bottom one is just 1 factorial, which is just 12. And 3 choose 3, so that means the top you have 3 times 2 times 1, there were 3 numbers. And here the bottom is 3 factorial, therefore you cancel that, which is just 1. And this should make sense, very intuitive. Just ask yourself, how many ways to choose 3 students from 3 students? Only 1 way, you just choose them all. Okay, so those are the regular one. Let's look at some irregular one. So in this case, I cannot use the how many ways to choose 6 students from 5 students. Of course, there's no way you can choose it, right? Which is 0 way. So that kind of makes sense too. But let's follow the definition to do this calculation. So you're gonna do this. 5 times 4 times 3 times 2 times 1. Should you stop? Nope, you have only 5 numbers here so far. You have to continue down to another one. You're supposed to have 6 numbers here, divided by 6 factorial, which is 0 because of the 0. Alright, same idea, 2.5 choose 4. In this case, you cannot use the explanation saying how many ways to choose 4 people out of 2.5 people. There's no way you can explain that. So this is, we cannot do that. We can do that only if they are integers. So in this case, we are going to follow the definition. It will be 2.5 times one less, which is 1.5, times another one less, which is 0.5. And then keep multiplying, so subtract 1 again, negative 0.5, divided by 4 factorial. So if you do the algebra, it's about negative 0.0390625. Okay, so that's not the it's different from what we have done in ABC. Okay, similarly for F, you are gonna do negative 2 times negative 3, just keep subtracting 1, okay? And then times negative 4, just keep subtracting 1 over 3 factorial, which is negative 4. And I suppose you can do the other two. So, but that's how we are gonna compute the binomial coefficient